Okay, so we'll be doing October November 24, paper 4.1, question 2 now. So this question is an object-oriented programming question. So let's start. A computer program is designed to simulate horse doing jumping. In show jumping, horses jump over obstacles called fences. The horse successfully jumps a fence if it does not knock out the fence down. The program is written using OOP. The class horse will store the data. It will have some name, some maximum height, some percentage, a constructor, and some getters, and then a success method. So write program code to declare the class horse and its constructor. Do not declare any other methods. So this will be class of horse, and they're saying the constructor as well. So constructor will initialize name. So all the attributes will be initialized. So define dash dash init dash self, and they're saying all the attributes must be private, and then the type declaration must also be written as comments. Okay, so there would be three parameters. Now we'll have self, we'll have name, we'll have max fence height, and we'll have percentage success. So self dot dash name is equal to nm, then self dot dash we have the max fence height is equal to mfh, and then self dot dash percentage success is equal to ps. Okay, then we have to add comments here. So this would be a string. Let's call it str. Then this would be an integer, and then this would also be an integer. Okay, then in the next part they're saying the get methods, get name and get fence height, each return the relevant attribute. Write the program code for the getter methods. Okay, this would be typical getter method. So define get name, so this would get you the name, it would return you the value of the name, and then this would be get return, and this would return us the max fence height. Okay, then the question says array horses stores objects of type horse. Okay, the program has two horses, a horse named this, and then write code to declare the array horses local to the main program. Okay, so outside the class we have to create a main program. So it would be something like this, main, and then here we have with space for two horse objects. Okay, so we'll create the array horses, and it will have two horse objects. Okay, so it will initially be empty, and then we'll create two horse objects. So the name of the class is horse, so let's call it h1 is equal to horse, and the name would be beauty. Then maximum fence height is 150, and then success rate is 72%. Then we have horse 2. It will also be a horse, and it would be of type, and the name would be jet. The height would be 160, and success rate would be 65. Now they're saying that you have to store both the horses in the array. So we'll just say horses dot append h1 and horses dot append h2, and then output the name of both horse objects from the array. Now in order to output the name, okay, so in order to print the names, we have to get the values from the respective indices, and we'll simply write the name of the array, which is horses, and then we'll go to index 0, and then we'll get the name stored there, which will be beauty, and then we'll go to index 1 and we'll get the name, which would be jet. So then we can print name 1 and name 2 together. Alright, then they're saying test the program and take a screenshot of the output. So let's test the program, and it prints beauty and jet. So this is working fine. Alright, next part is part C. The class fence stores the data about the fences. Each fence has a height in centimeter and a risk number. Okay, this is going to be another class. We'll hide this. This is going to be a class fence. Okay, The risk, the risk is a whole number between 1 to 5. 1 means the fence is easiest to jump, and 5 means the fence is harder to jump. Okay, so we'll just 1 is easy and 5 is equal to tough. Okay, a risk of okay, so we have the risk, we have the height, we have the constructor, get height, get risk. It says you have to write fence and the constructors and the getter methods, all attributes must be private, and then we have to declare the attribute as comments, their types. Okay, so we'll have the constructor here, which would be, it will have two parameters, height and risk, and then we'll say self dot height is equal to ht, and then self dot dash risk is equal to rk. Then we are saying you need to make the getter method as well. So this would be define get height and return the value of height, and then get risk and we get the value of risk. All right, then that some sort of a conditional loop would be created, okay, to make sure that the values are inputted correctly. So amend the main program to declare the local array course. Okay, so we'll go into the main program now and we'll create an array course, and then they're saying take as input the data for 4 fences from the user, okay, and then loop in the input until both the height and risk are valid for each fence. Okay, so first we have to check what is the criteria for validity here. So height is supposed to be between 70 and 180. So I'll just comment it here, 70 and 180. And then the risk is supposed to be between 1 and 5. Also we need to declare their types as well. So this is an int and this is also an int. These ranges are just for our convenience. Okay, so we create an array course. Then they're saying take as input data for 4 fences from the user. So when we have 4 fences, that means we'll have 4 heights and 4 risk values, right? So we have to loop until both the risk values are each fence, create an instance of fence for each of the 4 valid fences, and store each instance in the array. Okay, so we created an array called course. Now we have to input 4 fence values and we have to validate them. So we'll use a for loop for I in range 4. Okay, and now we have to use a while loop for validation, right? And before we do this, we should actually take inputs of the values. So what are the two properties of fence? That is the height and the risk. Yes, height and the risk. So we'll get those. So height is equal to int input enter fence height, and then we have the risk equal to int input enter risk for fence. Okay, so we run a while loop and we check while the conditions were height should be between 70 and 180. So while height is less than 70 or height is greater than 180, right? So either one of these, and the risk is less than 1 or risk is greater than 5. If any of these conditions are true, then that means that the values are not valid, so we have to input them again. This is one way, but in this case, even if one value is wrong, we'll be re-inputting both of the values. So it depends. You can just take one value input at a time and then validate it and then move on to the next one. So in fact, let's do that as well. So something like this. We run a loop directly and we check while height is less than 70 or greater than 180. We are going to just input the value again. Like this. Eventually, there would come a point where the values in range of the loop will end, and then for risk, we'll do the same thing. Int input, enter risk for fence, and then we'll again run a while loop while risk is less than 1 or risk is greater than 5, and we'll re-input the value of risk like this. And this would make sure that both values have been validated. And once the correct value has been sought in this loop and in this loop, and then the loops would end, and within the for loop here, for the 0th iteration, for the 1 iteration, 2 iteration, we're going to add the value into the course array. Okay, so course array would be append. So we'll be appending the, let's call it current fence, into the array, and the current fence would be current fence is equal to fence, and this will get the parameters of risk and height. And this whole thing would repeat 4 times, and by the end of it we'll have 4 objects of the class fence in the array course. So all of this is done. Now let's look at the part D. So in the part D, they're saying the chance of a horse jumping a fence without knocking it down is calculated as follows. If the height of the fence is more than the maximum height a horse can jump, the success percentage is 20% of the horse's percentage success. This risk does not affect the value. When the height of the fence is less than or equal to the maximum height a horse can jump, the risk modifier gives a value to multiply with the horse's percentage success. The risk values and their modifiers are. Okay, so we are given some height. This is the maximum height that the horse can jump. And then they're saying that the height of the fence that would be given to you would basically lead to a percentage success being calculated. So if, let's say, the horse is able to do a maximum of 70 to 180, and if you give it a fence of 200 in height, then the horse wouldn't be able to jump over that fence, and then the probability of success would reduce. Similarly, if you give it a fence of height 60, since 60 is less than the minimum value, so the probability would be 100%. Okay, so if the height of a fence is less than or equal to maximum height, the risk gives the modifier value to multiply with the horse's percentage success. The risk values and their modifiers are given in the table. For example, Jet has percentage success of 65 and max fence height of 160. Okay, percentage. Alright, then a fence has a height of 140 and a risk 3. The height of the fence is less than the max fence height. Okay, so the horse's max fence height is 160 and the fence has a height of 140, which means the horse would most likely be able to jump through it. Therefore, the risk is used. Okay, since it's less, so here we should write it. So we'll be writing a method function in the horse class. This would be called success method. Okay, so again what we have to do is, if the horse's max fence height is less than or equal to the fence height, okay, then what we'll do is we'll simply, so if that is the case, we're just writing the logic now. So what we'll do is we'll simply multiply the risk gives the modifier to, yes, so what we'll do is we'll multiply the value of modifier times the percentage success. will multiply these two values. Okay, if that is not the case, what do we do? So then the success percentage is 20% of the horse's percentage success. Okay, so we'll multiply 0.2 into percentage success. That's it. So if the maximum fence height that the horse can climb is less than the current fence, then we multiply the value of success by modifier. Otherwise, if the fence height is more than the horse's capability, we'll simply multiply by 20% of the percentage success, right? So I'll just comment this out. It's not part of a code. Okay. So since the height of the fence is less than the max fence height, therefore the risk is used, and the risk of 3 gives the modifier 0.8. Okay, the modifier 0.8 is multiplied by horse's percentage of 65, which gives 52. The chance of horse jumping the fence goes up by 52%. So the risk would be given to us, and then corresponding to that we are going to take this modifier and we are going to multiply it by percentage success. In our case the percentage success was 65, so we simply multiply 0.8 by 65 and we get 52%. So the method success in the horse class takes the height and the risk of fence as a parameter. Okay, so the height and the risk as a parameter, then calculates the percentage chance of success for that horse jumping without knocking it down, returns the calculated percentage success. Okay, so let's try this. So we'll directly start. So if the risk is equal to, so in fact first we'll check for this condition, if the horse's maximum fence height, this, so if self-taught maximum fence height, like this, we should use a getter method. Max fence height is equal to get max fence. In fact we can access it directly, so this should be if max fence height, if that is if the current height is greater than, let's call it the fence height. Okay, so there's no confusion. So if the fence height that the horse is going to climb right now is greater than the maximum capability of a horse, then what we're going to do, we're simply going to do this, we're going to multiply it by 0.2 of the percentage success. So we'll say return 0.2 times percentage success, and to get percentage success we'll use this variable. I'll just copy it, and that's it. Else if that is not the case, if the fence height is less than or equal to the horse's capability, then we need to get the modifier, right? So how do we get the modifier? So modifier, let's say modifier is equal to, or let's just write if conditions. Okay, so if the risk is equal to 1, like this, then the modifier becomes equal to 1.0, right? If risk is equal to 2, then modifier becomes equal to 0.9. Then if risk is equal to 3, modifier becomes equal to 0.8. So we keep on repeating this. Okay, so once we have the modifier here, so what we have to do now is we simply have to multiply it with the percentage of progress. So we'll say return modifier times the self-taught percentage progress of the horse, and that is the whole complete answer, right? Okay, so they're saying it might be referenced before assignment, so we can make it 0 initially, just to make sure that in case none of these conditions work, it should return a 0. Just an error handling. So that's it. Or an easier method could also have been that instead of storing all these values in modifier, we could have just simply returned 1.0 times self-taught percentage success. Okay, I just did it for a bit more explanation. Okay, so this part is done, success part. Then we have part E1. So part E1 says write the program to amend the main program. Okay, so let's hide all of this code. Okay, here we go. Then they're saying calculate and output the chances of first horse jumping each of the 4 fences without knocking each fence down, and output the chance of second horse jumping over each of the fences without knocking them down. All outputs must have appropriate messages, including the names. An output example would be like this: the horse fox at fence 1 has a 68% chance of success. Okay, so we just have to output the values. So in order to do part E, we'll be going to the main program, and since we have 2 horses here, so we can either run 2 loops, or we can do it using a nested loop. So 4 within a 4 like this. So if we do it using a nested loop, so for let's say h in range of 2, right? Or we can say for h in horses like this, and for f in fences. So this will get us the object. What is the name of the array? Course, like this. So this will get us the course, and we can just access the values one by one. So we'll print. So the outer loop will get us the name of the horse. So we'll say, it says print the horse. Okay, so we need to get the name of the horse. We'll get it using the object h, using the h or get name. Name is at fence. Okay, we need to get the fence number now. So fence number would be this one. This would be fence 1. Fence. We have 4 fences here. Okay, so for here we need to use a loop for f in range of 4. Okay, so at fence number, this would be f plus 1, because this is the fence number 1. Okay, then it says has a 68% chance of success. So here we have to call the success function. So in order to call the success function, we have to use the horse object h dot, what was the name of the function? Success, right? So we'll call success here. Okay, and we need to pass in the current risk and the current risk and the current risk and the current height. So that is stored in the course array. So we'll say this will get from the course index f dot, this would be the risk value, dot get height and get risk. So we have two getter methods, get height and get, yes. So it would be get risk. So this would be, first one would be to get, first one would be the height, yes. So this would be get height. So we get the first value, and then similarly we get the risk value. That's it. So what did we do? We are saying get the horse name, which we'll get from the object h, which would be stored in the array horses, add fence, which would be f plus 1, which is the for loop variable. So if when it is 0, so it would be 1, then 2, then 3, then 4. And then we have the, we're calling the success rate from the success function. Here we are passing in two parameters. One would be the height, the second would be the risk. And then they're saying the chance of success has a this much percentage chance of success. And with it, the question is done.